Okay, we were in section 9.8 yesterday. And there's one last thing we have to finish in section 9.8. Section 9.8, we were looking at power series. What's a power series again? Has a to the n times, or a sub n times.
X minus c to the n.
So it was a function, f of x is the sum from n equals 0 to infinity of a sub n times x minus c to the n. And we would say that's a power series centered at c. And what we did yesterday is we looked at, for different possibilities of a sub n, we looked at the different possibilities for when does that series converge and diverge, which was another way of saying what's the domain of that series. But the important thing is that is a function. And when you have a function, you can do things to functions. What kind of things do we like to do to functions in calculus?
Integrate.
We like to integrate, and we like to take derivatives. Those are the two things we like to do. How do you take the derivative of this function?
Take the limit.
All right. Now, it's very easy. You're going to be very happy. Remember that a sub n is just, a sub n is a variable in a sense, but it has n in it, right? Not x. So this is a sub 0 x minus c to the 0 plus a sub 1 x minus c to the 1 plus a sub 2 x minus c squared plus, and it goes on forever and ever and ever. What's the derivative? What's the derivative of a sub 0 x minus c to the 0? Well, what's x minus c to the 0? 1. What's the derivative of a sub 0 times 1? 0. Why 0? Doesn't have any x's in it, does it? It's a constant. 0. Plus, what's the derivative of a sub 1 times x minus c to the first?
X.
Not x.
X minus c.
X minus c, you're getting closer. X minus c to what power?
To that 0.
To the 0. Why 0?
Drop power down, subtract 1.
You bring the 1 down, you subtract 1 from your power, and then you take the derivative of the inside, but the derivative of the inside is just 1. So that's a sub 1 times x minus c to the 0. Plus, what's the derivative of a sub 2 times x minus c squared? 2a sub 2 times x minus c to the 1. You bring the 2 down, you subtract 1 from your exponent. Plus, what's the next one going to be?
3a sub 2.
3a sub 3 times
X minus c squared.
x minus c squared plus. So what are you doing for each term?
Power rule.
That's your power rule. You bring the power down, you subtract 1 from the power. So how do you take the derivative? It's the sum from n equals 1 to infinity of a sub n times, you bring the power down, n, x minus c, and you subtract 1 from your power. Here's the big question though. This one started at 0. Our original function started at 0. Why, when I took the derivative, does our series start at 1? Nick?
When it starts at 0, it's just 0.
What was the derivative of the first term? The derivative of the first term was 0. Would it matter if I started this series at 0? No, why not? Because when I plug 0 in for n, I'm still going to get 0 right there, aren't I? I'm going to get 0 for the whole thing. But typically we started at 1. When you take the derivative, you start at 0 here. Take the derivative, you start at 1 there. But the truth is, you could start at 0. There's nothing preventing that. It's just that the 0th term doesn't really do anything. Put 0 when you get 0. The other big theorem here is that f of x and f prime at x have the same radius of convergence. What does that mean?
The distance that the convergent values travel from the center is the same.
Correct.
But the center is the center the same?
The center is the same, right? They're both centered at C. This one's x minus c, it's centered at C. And that one's x minus c, they're both centered at C. So, what it means is, if the radius of convergence is r, they both converge for x minus c less than r. But there is a little bit of a weird thing that can happen. Yesterday, when we looked at radius of convergence, sometimes we found that if we wrote our answer this way, that maybe it came out to be x minus 1 less than 3 less than negative 3. So we ended up with something like negative 2 less than x less than 4. Sometimes we saw that maybe the series will converge when x equals 4, but not when x equals negative 2. That can change when you take the derivative. It's possible that the original series might converge at 4, but when you take the derivative, it may no longer converge at 4. Or it can go the other way. The original series might not converge at negative 2, but when you take the derivative, it might converge at negative 2. Again, you would just have to check it to see if it converges at the endpoints or not. But you're guaranteed, if the original function converged on negative 2 less than x less than or equal to 4, then you would be absolutely guaranteed that the derivative would converge on negative 2 less than x less than 4. You would just need to check the derivative, check each endpoint, and see if it converges there or not. Okay? Well, if we take the derivative by simply pulling the power down and subtracting 1 from the power, how do we take the integral?
Divide and add 1.
You add 1 to the power and divide by the new power, just like you do for integrating traditionally. So if f of x is the sum from n equals 0 to infinity of a sub n times x minus c to the n, then the integral of f of x dx is the sum from n equals 0 to infinity of a sub n times x minus c to the n plus 1 divided by n plus 1, thank you very much, plus c, absolutely, plus c when we do an integral. Very good. Feel that nasty little plus c there, that's easy to forget. And the exact same theorem holds, that these will have the same radius of convergence. And again, weird things can happen at the endpoints. Again, the original function might converge at 4, but not negative 2. The integral might not converge at 4. Again, you would have to check it. Questions on that? Okay, so we will actually use these facts in section 9.9. Writing functions as power series. All right, well, typically we start with the most famous power series. I don't know about the most famous, but the easiest one to write as a power series. We start with the function 1 over 1 minus x. And I'm going to take 1 over 1 minus x and write it as a power series. How am I going to do that? Yeah, I want to write it as a sum of something. So I want 1 over 1 minus x be written as the sum from n equals 0 to infinity of something. And by the way, I'm going to have it centered at 0. Well, here's the idea. 1 over 1 minus x looks a lot like a over 1 minus r. What do you know about a over 1 minus r? That's the sum of a geometric series. That's the sum from n equals 0 to infinity of a times r to the n. And when does that converge? When r in absolute value is less than 1, which can be written as r is between -1 and +1. So if I have 1 over 1 minus x, what's my a? 1. What's my r? X. So what's 1 over 1 minus x written as a power series? It's x to the n. What's its radius of convergence? Converges for -1 to 1. Why? Because the other one did. Same rule. If I plug in any number for x, any number between -1 and 1, I will have a geometric series, and that geometric series would converge. If I plug in a number bigger than 1, I would still have a geometric series, but it would be a divergent geometric series. Questions on that? Okay. So from there, how about if I gave you 4 over 2 minus x, and I asked you to write that as a power series? Well, what you want to do is you want to get it in the form a over 1 minus r. Is that in the form a over 1 minus r? No, what's wrong with it? It's got a 2 right there. So how do I make that 2 disappear?
You divide by 2.
Divide by 2. So I'm going to divide everything by 2. So that's 2 over 1 minus x over 2. Is it now in the form a over 1 minus r? It is. So this is the sum from n equals 0 to infinity. What's my a number? 2. What's my r? X over 2. So that's going to be x over 2 to the n. What's the radius of convergence for that one?
-2 to 2.
Excellent. Why -2 to 2?
Because then it gives you r equal to 1.
Because our r value has to be between -1 and 1. So we have to have -1 less than x over 2 less than 1. And we multiply everything by 2. That one converges for everything between -2 and +2. Questions on that? Okay. How about write 1 over 1 minus x as a power series centered at, give me no number except for 0.
4.
All right, so how do I get this to be centered at 4? What do I need? Well, when I get done, my answer is going to look something like that. What has to be inside this parentheses if this power series is going to be centered at 4?
-4.
I have to have an x minus 4, don't I? I might have to multiply by something or divide by something like I did in this previous example, but I need an x minus 4. If I need an x minus 4 here, then what does that tell me about this? I need instead of an x right there, I need a x minus 4. Okay, so what you have to do to center it at 4, you're going to take 1 over 1 minus x, and you're going to write it as 1 over 1 minus x minus 4. But those aren't equal. I can't just slap a negative 4 in there and have those equal. What do I have to do to fix it? Add a 4? Close. I actually need to subtract a 4. Why do I need to subtract a 4?
Because you have 1 minus x minus 4.
Because this minus 4 is inside this parentheses and it's going to minus out here. So what I've really done at this point to the bottom is I've really added 4. So if I add 4 to the bottom, I have to fix it by subtracting 4. Okay, so you start by making your centering correct. And then you got to simplify. So this is 1 over negative 3 minus x minus 4. I combine 1 and negative 3, 1 and negative 4, and made negative 3. Almost done. What do I have to do now?
Divide by 3.
Close. Further away. Not divide by 3, but divide by negative 3. Because I need to be this a over 1 minus r. I need this to be the number 1. So if I'm going to make this the number 1, I have to divide by negative 3. So this is going to be negative 1/3 over 1 minus x minus 4 over negative 3. Why do I write it as x minus 4 over negative 3? Why don't I write it as 1 plus x minus 4 over 3?
It needs to be in the form a over 1 minus.
I need it in the form a over 1 minus r. So I need that minus sign there. That's why I leave it there. So my final answer is to write this as a power series. What's my a number?
-1/3.
-1/3. What's my r?
X minus 4 over negative 3.
X minus 4 over negative 3. Which is a correct answer, but would not normally be written that way. Normally what we would do is we would rewrite this, the sum from n equals 0 to infinity of -1/3 times x minus 4 to the n times -1/3 to the n. What did I do there? Just took it apart. Why do I take it apart like that? What can I do with this -1/3 and that -1/3? I can add the power. So final answer, you would normally see this written this way. This is a sum from n equals 0 to infinity of -1/3 to the n plus 1 times x minus 4 to the n. And why do we prefer to write it that way? Any reason?
Telescoping series.
Not telescoping. What's our general form for a power series? Oh, I've written here. For power series, we usually have, what do we have in front of the x minus c? We normally have a single term, a to the n, and then we have an x minus c to the n. So we're writing it in that form. The other thing it does is it shows, makes it pretty clear what's going to happen with this. What kind of series are you going to have? What?
Alternate.
It's going to be alternating. That's correct. Because you have -1 to a negative number to a power. That's going to be an alternating series. When does that series converge? Four? Nope.
X is greater than 3 and less than 5.
Nope, but you're closer. What was our R value?
X minus 4 over 3.
So we would need -1 less than x minus 4 over 3 less than 1. That's when that would want to converge.
So you drop the -3 out of that?
Yes, why do we drop the -3? Because normally we write this as absolute value of x minus 4 over -3 less than 1. To drop the absolute value of -3 is +3, and then split it that way. So to find the radius of convergence, you would first have to multiply by 3 and then add the 4. So if I multiply by 3, that's going to be a -3, add 4, that's a 1. Multiply by 3, add 4, that's 7. So that one would converge between 1 and 7. Questions on that?
What would R be?
R would be 3 because we're centered at 4 and we can go 3 steps to the right and 3 steps to the left. Other questions? Okay. Determine the power series for 1 over x at x equals 1. So I'm going to start with 1 over x. But the first thing I want it to do is I want it to be centered at 1. So how am I going to make it be centered at 1?
X over x minus 1.
I need a 1 over x minus 1. But if I put a -1 there, I have to balance it with a
Plus 1.
+1. Okay, so I'm going to rewrite that. That's 1 over 1 plus x minus 1. Is that written in the form I need it to be? Not quite. I need a over 1 minus something. Unfortunately, I have a plus something. So how do I fix that? Do what? I heard about 3 things. Okay, so we're going to write this as 1 over 1 minus. Molson's idea was to write it as 1 minus x, which would be okay. That would work. Typically, the way it's written is we write it as 1 over 1 minus x minus 1 over -1. Or, of course, I could do it times by -1 also. Either way would work. Now we're written in the form a over 1 minus r. So this is the sum from n equals 0 to infinity. A is 1. R is x minus 1 over negative 1. And again, typically we would split this out. We would write this as the sum from n equals 0 to infinity of negative 1 to the n times x minus 1 to the n. Pull the negative 1 out, but 1 divided by negative 1 is negative 1. So there's where the negative 1 to the n came from. Questions on that? What's the radius of convergence? Or what's the interval of convergence? One or the other.
Between 0 and 2.
Between 0 and 2. Why between 0 and 2?
Multiply by 1 and add 1 to each side.
Multiply by 1 and add 1 to each side. Okay?
Of x minus
Yeah, normally we would start with negative 1 less than x minus 1 less than 1. Multiplying by 1 doesn't do anything, but the adding 1 is the important step. Add 1 to everything. Does it converge at the endpoints? If I plug 0 in, do I get a convergent series? Now let's start with 2. If I plug 2 in, what's 2 minus 1? What's 1 to the power? 1. So if I plug 2 in, I have that series. Is that a convergent series? No, why not? It is oscillating. And it's oscillating between, each value would oscillate between negative 1 and positive 1. So when I take the limit as n goes to infinity of negative 1 to the n, do I get 0? No, it's oscillating between negative 1 and positive 1, so my limit is undefined. So it would diverge by the divergence theorem. So how about when I plug in 0? When I plug in 0, what's 0 minus 1? What's negative 1 to the n times negative 1 to the n? It's the same as 1 to the n. Is that a convergent series? If you take 1 plus 1 plus 1 plus 1 plus 1 and add it over and over again? No, so it doesn't converge at either of the endpoints. All right, next thing I want a power series for ln of x. Centered at x equals 1. How do I find a power series for ln of x?
Take the derivative of ln of x.
If I take the derivative of ln of x, what do I get?
1 over x.
And I have a power series for 1 over x. So if I know the power series for 1 over x, how do I get the power series for ln? Integrate. So we know that ln of x is the integral of 1 over x dx. And that's why I covered that little integration rule in section 9 point, whatever the previous section was. I forgot what number I'm on. 9.8, I think. So we integrate. That's going to be the sum from n equals 0 to infinity of negative 1 to the n. I add 1 to my power. That's x minus 1 to the n divided by n. Charles isn't going to remind me this time, apparently. Plus c. How much is c? C is a number.
1.
Not 1, but you're not far off.
0.
0. Why 0? It doesn't matter. Well, it does matter if it's not 0, but if it is 0, it doesn't matter.
Is it more something you told us?
Maybe automatically would average if it was anything other than 0?
No, because this is not part of the sum. This would just be added up, and then when you get all done, add 5, or whatever this number c is. I'm going to pick my favorite number in the whole wide world for x and plug it in. What's my favorite number in the whole wide world for x to plug in?
0.
I can't plug 0 in. ln of 0 is undefined. 1. What's ln of 1? 0. ln of 1 is 0. What happens when I plug 1 into this series? I get 0. So if I plug in x equals 1, 0 equals 0 plus c, which means c has to be 0. C is the number 0. All right, so ln x is the series, the sum from n equals 0 to infinity of negative 1 to the n times x minus 1 to the n over n. And we know, we're guaranteed, that it will converge between 0 and 2. If I plug 0 in, will this series converge? If I plug 0 in, what's 0 minus 1? Negative 1. And then I would have negative 1 to the n, but I would have that times another negative 1 to the n. What's negative 1 to the n times negative 1 to the n? 1 to the n. And 1 to the n is 1. So if x equals 0, this becomes the sum from n equals 0 to infinity of 1 over n. Does that series converge or diverge? Diverge. How come? It's the famous harmonic series. Did we expect it to converge? Can you plug 0 into ln? No. So we would have had a big problem if we would have had a big problem if we could plug 0, not plug 0 into that side, but we could plug 0 into that side. Something would have been really wrong. How about when x equals 2? What's 2 minus 1? What's 1 to the n? 1. So when x equals 2, this becomes a series n equals 0 to infinity of negative 1 to the n over n. What can you tell me about that series? Converge or diverge? Converge. Why does that one converge? It's the alternating harmonic series, isn't it? And we have shown that the alternating harmonic series converges by the alternating series test. So here's an example of where the domains change slightly. The domain for the original function was just between 0 and 2, but when we integrate, we get to add the number 2. We also just proved another interesting fact. We just proved that the sum from n equals 0 to infinity of negative 1 to the n over n is, what's the sum of the alternating harmonic series? It's ln of 2. Because when I plugged 2 in, over here I would have ln of 2. And when I plugged 2 in here, I got the alternating harmonic series, which we know converges. So this alternating harmonic series must converge to ln of 2. Questions on that? Nick?
When we did the integration, when did we add 1 to the power?
Oh, I guess I didn't. This should have been n plus 1, and n plus 1, and n plus 1, and n plus 1. Which means that one's an n plus 1, and that one's an n plus 1. But this one's still divergent. Why is this one still divergent? You could do the limit comparison test with 1 over n. And this one's still convergent because same thing, it's an alternating series. You can use the alternating series test.
Plus 1 there.
Need a plus 1 there. But this is still the alternating harmonic series, because if you write out the first few terms, what do you get when you plug 0 in? You get positive 1, because negative 1 to the 0 is 1, and you get 1 on bottom. When you plug 1 in, you get a negative 1 over 2. When you plug 2 in, you get a 1 over 3 minus 1 over 4 plus 1 over 5, so on and so forth. It's still the alternating harmonic series.
Would the x equals 0 one be negative?
No, because what's negative 1 to the 0? What's anything
No,
right?
I mean for the other one, where it's just the harmonic series and we showed it was divergent, wouldn't it be negative 1 over n plus 1?
This one? Or this one?
That one.
No, because for... Oh, yeah, does it change it? Because if I put 0 in, I'm going to have negative 1 to the n plus 1 times negative 1 to the n.
So one of those is going to be positive and one of those is going to be negative every time.
So it's still going to alternate? No, that can't be right.
I don't think it changes anything. I just think that it's...
Well, if it alternates, then it converges, and that's a bad thing. I don't want it to
Yeah.
converge.
No, I don't think it alternates. I'm saying like the negative 1 to the n and then the other negative 1 to the n plus 1. Wouldn't that be negative 1?
What's negative 1 to the n times negative 1 to the n plus 1? That would be negative 1 to the 2n plus 1. Is that right? You add your powers. So you're right, that's just going to be negative 1, isn't it? Because this power is always going to be an odd number. So you're right, it would just be negative 1. So it would be negative 1 over n plus 1, but it's still a divergent series. You still compare it to 1 over n. Other questions? It's a lot easier when I didn't add the plus 1. All right, the last famous one. This goes back a ways. What's the derivative of arctangent of x? Not arcsecant. The derivative of arctangent of x was 1 over 1 plus x squared.
Definitely go further.
I'm going to take 1 over 1 plus x squared, and I'm going to write it as 1 over 1 minus negative x squared. And then what do I have?
A over 1 minus r.
I have a over 1 minus r. So this is the sum from n equals 0 to infinity of, what's my a number? 1. What's my r?
Negative x squared.
Negative x squared to the n. So that's the sum from n equals 0 to infinity of, I'm going to write this as negative 1 to the n, x to the 2n. I would multiply my powers there. So there's the power series for 1 over 1 plus x squared. So what's the power series for arctangent? I integrate again, don't I? This is going to be the sum from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1 over 2n plus 1. What's the arctangent of 1? Tangent of what angle gives you an answer of 1? 45 in radians? Pi over 4. So pi over 4 is the arctangent of 1, which would be the sum from n equals 0 to infinity of negative 1 to the n times 1 over 2n plus 1. So, did you ever wonder, how do people work out pi to like 100 places, 1,000 places, 1,000,000 places? How do they do it?
A lot of free time in this equation.
A lot of free time. And they use infinite series. Now, the reality is they don't use this infinite series. This one does converge. It converges to pi over 4, but it converges very, very slowly. You would have to use many, many, many terms to get an accurate answer. In your book, they point out a much better one. Where was that? I saw that somewhere on here. One of the more famous recent estimates of pi came from an Indian mathematician named Ramanujam. And Ramanujam proved that 1 over pi was equal to that pretty series right there. Pretty. Look at those nice things. It's got a 4n factorial. It's got an n factorial. 396 to the 4n. And of course, you've got to have a 26,390 there. But what happens with this series? Of course, you got square root of 8, and all sorts of interesting numbers here. What happens with this series? By plugging in one more number. So if you plug in 5, you get an estimate of pi. If you plug in one more number, you get an estimate like 8 more digits accurately. And then one more number, you gain like another 8 digits. So this series converges very, very quickly because of these big numbers down on bottom, the n factorial, the 396 to the 4n. This one converges very, very quickly. And this has been one of the more recent techniques as a way to approximate pi to many, many decimal places. Questions on that?
Will that number keep going forever like pi?
Yes, absolutely. Yeah, since pi is an irrational number, 1 over pi is an irrational number. Yep. Other questions?
So is there like a function like similar to that one or that one like in our calculator that it does every time we hit pi?
My guess would be that your calculator just has a stored value. My guess would be it's just hard coded in somewhere.
Right.
That would be my guess. I truthfully don't know. That would be a lot easier. Yeah, that's my guess. But my guess would be when you type in sine of pi over 12, your calculator has some series approximation that's ugly like this one, but began with the power series, not the power series, but the Taylor polynomial and the Maclaurin polynomials that we were looking at. That would be my guess. It's not a nice, pretty one.